Regardless of what kind of multiplayer game you have in mind, chances are that Coherence has got something for you. But as we do things a bit differently, it might be hard to orient yourself at the beginning. In this short video, we'll see some concepts that are central to our tech. At the first stop, let's talk about network topology. In Coherence, at the heart of the network topology, there is always a replication server, or RS for short. The replication server is a smart relay. It is a lightweight executable that is engine agnostic and is written by us, and we can run it for you if you choose in the Coherence cloud. It has an overview of the state of the world at any given time, and it is in charge of replicating it among all of the connected clients, relating messages between clients, and also manages entity authority. You don't need to create game-specific replication servers, but rather you launch replication servers providing a description of your netcode, which we call schema. But don't worry, because we also take care of generating the schema for you, so it's all automated. When you build a game in Coherence, you, the game developer, will mostly be concerned with creating the game client. This is basically the game, and is most likely made in a commercial game engine. It can, for instance, be made in Unity, and in fact we do provide an easy-to-use Unity SDK, so you can make the game client talk with the replication server. Many types of games will work fine with a topology that just includes the clients and the replication server. This organization means that the clients are running the whole game code, distributing the authority of network entities between themselves. If you come from other networking solutions centered around the idea of a host, well, in this picture there's no host as such. All clients drive the simulation together. This is actually really nice because since there is no host, if one of the clients were to disconnect, the state of the world would be preserved on the replication server. So other clients can continue to play, and the one who fell can rejoin. This topology is great for a co-op game, where each participant runs their own character, and maybe they run the traps, or the triggers, or the enemy, or anything really. In this scenario, no server-side logic is present, which also keeps the cost of running this type of games quite low. We have a good example of this topology in one of our demos, First Steps, where we even show how to use this to create a simple and distributed physics simulation. Again, not suited for competitive games, but hey, great for co-op. However, there are types of games where you do need server-side logic. For this, in Coherence, we provide something we call simulator. Differently from the replication server, a simulator is a special version of the game that runs in the cloud. If your game is made in Unity, the simulator is probably a Unity executable, and because of that, it can run Unity code like physics, pathfinding, AI, ECS code, jobs, and whatnot. A simulator is also the ideal place to host data-sensitive code like calls to external services or databases. The fact that the simulator is a Unity instance also means that you can program netcode in exactly the same way as if you were programming it for a client. In fact, one of the coolest options in Coherence is the ability to quickly change an entity that is server-side to be client-side and vice versa. This unlocks interesting possibilities. If you structure your game correctly, you can easily have two versions of your game, one that is cheat-proof but more expensive to run, and one that is completely client-driven, but cheap or even free to run. And we'll talk about this free option later. So in a way, you could think of a simulator as just another client with special powers, running in the cloud. But both clients and simulators still have to connect to the replication server, which is always at the center of any topology in Coherence. So again, we can't call the simulator the host either. It's just one piece of the puzzle. Another cool opportunity that this model allows for is to have multiple simulators. We covered this in our video on load balancing, but in essence, the idea is to just have multiple simulators and to spread simulation of a big world among them. This is simply done by distributing the authority on network entities, whether it's enemies, the player characters, or more abstract concepts like the status of a party of heroes among different simulators. This authority can then move from simulator to simulator to distribute the load. Finally, we have been talking about all of this in the context of the Coherence Cloud. Both the replication server and the simulators can run in our cloud, and we can take care of scaling this for you across regions and number of players. The Coherence Cloud is an incredibly convenient option for both developing and launching the game. It comes with a free tier, and it's a zero-click configuration. But there might be situations where you want to do without the cloud and give the game in the hands of your players. Some call this peer-to-peer, and we call it client hosting. At this point you should be able to guess what this means. The client is acting as the host. Host of what? Well, of course, of the replication server. So in this model, the replication server runs on one of the clients alongside the game build. Other clients can then connect to this replication server using, for instance, the Steam Datagram Relay or Epic Game Services. And by the way, we have an example in our SDK. In this picture, because the Coherence Cloud is not there and we provide our SDK for free, the game is technically free to run if the relay is free too. And at least when recording this video, the Steam one, for instance, is. There is so much more to say, but we hope that this video will at least clarify a few base terms of how the Coherence model works and why it's so flexible. I'll see you next time, and have fun using Coherence.